The next thing we'll look at is called a telescoping series. And the easiest way to explain a telescoping series is through examples. So let's look at an example. Here I have the sum from 1 to infinity of 1 over 3 to the k minus 1 over 3 to the k plus 1. Let's start writing out some of these terms. I have 1 over 3 minus 1 over 3 squared. The next one is going to be 1 over 3 squared minus 1 over 3 cubed. This is going to continue to 1 over 3 to the n minus 1 over 3 to the n minus plus 1. And you'll see that this negative 1 over 3 squared and plus 1 over 3 squared cancels. And in fact, that's going to continue happening until we have two terms left, a 1/3 and negative 1 over 3 to the n plus 1. We then take the limit as n goes to infinity, and we get that the sum of this series is just 1/3. And this is the idea of a telescoping series. We're essentially going to have a lot of terms that are going to cancel. Let's look at another one. 1 over k minus 1 over 1 plus k squared. If I start writing out terms, I have 1 over 1 minus 1 squared, 1 squared minus 1 cubed, 1 cubed minus 1/4, and we'll continue until we have 1 over n minus 1 over n plus 1. Once again, you'll notice things start to cancel. And we're left with two terms once again, 1 and negative 1 over 1 plus n. If I take the limit as n goes to infinity, I get that this one adds up to be 1. Let's look at one that's slightly different. The sum from 1 to infinity of the square root of k plus 1 minus the square root of k. If I start writing out terms, I have root 2 minus root 1, root 3 minus root 2, root 4 minus root 3, etc., up to the root of n plus 1 minus root n. And you'll notice one term on the outside cancels with the term on the outside in the next one. So I have 2 and negative root 2, 3 and negative root 3, and this 4 is going to cancel with this negative root n. So now I have negative root 1 plus the square root of n plus 1. And if I take the limit as n goes towards infinity, I end up with negative 1 plus infinity. So this series is actually going to diverge to infinity. Let's do one more. 1 over k minus 1 over k plus 2. If I write out terms, I'll have 1 over 1 minus 1/3 plus 1 over 2 minus 1/4 plus 1 over 3 minus 1/5, etc. And this time I'm going to write two terms at the end. A 1 over k minus 1 minus 1 over k plus 1. And then plus 1 over k minus 1 over k plus 2. The reason I did that is because you'll notice this 1/3 cancels with a 1/3 that's 2 parentheses away. This 1/2 is going to actually cancel with this term here. Oh, sorry. That 1/2 actually doesn't cancel. This 1/4 is going to cancel with this term. And this 1/5 is going to cancel with this term. We're actually left with more. A 1, a 1/2, a minus 1 over k plus 1, and a minus 1 over k plus 2. If I take the limit as we go to infinity, I get 3/2. So it is possible that not as much stuff cancels, in which case we have to be a little more careful.